Hi, I'm Nigel Parker. I'm a web and mobile dev guy from Microsoft in New Zealand. I'm going to spend the next half hour taking you through the 5 things you need to know to start using video and audio today. I'm going to start by calling out the 2 new elements inside of HTML5. We have the audio tag and we've got the video tag. There's not that many attributes to each of these tags, and you'll see that they're quite common between the two. In addition to the source element, the video element also has a width and height, as well as a poster image that's displayed before the first frame of the video is downloaded. This preload element can be set to none, just the metadata to get the length of video and the resolution, or auto to start automatically downloading content. You've got to be careful if you're setting it to auto for mobile devices, because you're going to be effectively downloading video potentially through a 3G network. Autoplay, loop, these speak for themselves. And controls. So if you include controls, it's going to display the default play, pause, scrub bar, volume controls for both the audio and video element in each of the browsers. I'm going to start by talking about what I think HTML5 video and audio is good for. I think it's great for reaching an array of different mobile devices. It's also very good for doing CSS styling or accessing via the DOM or JavaScript and catering for new HTML5 drawing elements such as Canvas. What it's not good for is that it doesn't support content protection. So if you need to protect your content, HTML5 doesn't have anything in the spec that can do that today. Also, there's an issue around universal full screen. I'll touch that later in my talk, but it's very difficult to support full screen. Well, some of the browsers choose to support full screen, but it's not yet ratified in the spec, and there's still work around the security issues of popping out to full screen. Also, there is no current support for streaming of live video or adaptive streaming of video content. Now, you might be sitting there saying, well, I've actually used HTTP live streaming on an iPhone or an iPad, and thinking that that's actually part of the HTML5 standard. It's actually not part of the standard today, and Apple's HLS isn't in the process of being standardized. There is some work that's going on by 3GPP and MPEG, who are in the process of standardizing a protocol called DASH, which is Dynamic Adaptive Streaming over HTTP. At Microsoft, we have our Smooth Streaming protocol, which is a way of doing video chunking over HTTP, both for dynamic on demand or live video. And we're waiting and hoping that there will be a standardization of an industry format that we can actually look to support inside of HTML5. If we have a look over here at the audio and video codecs that are supported across the different browsers, you'll notice down the left hand side I've put all the common audio formats that are being used on the web, and on the right I've got the common video formats as well. I've got an exclamation mark next to Chrome for AAC audio and H.264 video. These are supported in Chrome today, but they've been quite public in stating that they'll be removing these from the Chrome browser in the future. There's also an asterisk next to WebM video, Vorbis WebM for IE9. And the reason for this is that we're not natively shipping the codecs for WebM, but you can install them as a plugin for IE9 to play back this type of video. If you're paying attention to the previous slide, you're going to notice that you are going to need more than one codec package combination to reach all of the modern browsers today. And you may also need to encode a high resolution and a low resolution version of your video in each codec if you're looking to support mobile devices over the cellular network, as well as HD or high resolution desktop clients. And unfortunately, this is unlikely to change anytime soon. YouTube has been, since the acquisition of On2 and the VP8 codec, they have joined with Mozilla and Opera and formed the WebM Foundation. And they've been re-encoding every video on YouTube into the WebM format away from H.264. Apple at the same time has been quite staunch in only supporting H.264 video on their iPad and iPhone devices. So unfortunately, I think the idea of a universal codec is still some time away. Let's take a look at some sample video markup. You'll see here this is the video tag. I've included the controls keyword to display the default browser controls. I have first a high resolution source MP4 file. It's important to put the type of the file and also the codec, the MIME type and codec, into the tag here so that the browser saves time and latency without needing to download the video to interpret this. There's a media attribute here that's looking at the minimum device width that's requesting the video. This is a good approach to say, well, if it's more than 800 pixels, serve the high resolution video. If it's less than 800, fall back to the low resolution MP4. Down below the MP4 files, I've also included OGV video files, a high resolution and a low resolution version for those browsers that don't support MP4. It's really important to note that the fallback content that is displayed next is only going to execute on browsers that don't understand the video tag. So if the browser understands the video or audio tag, it will not go into that fallback area. So you need to provide a codec that it can understand and play. The next thing I wanted to touch on is now you know that you need to create multiple codec types and potentially multiple resolutions. How do you go about encoding and creating that video? Well, one option is to offload the encoding to the cloud. And a couple of sites that I've tried for doing this is archive.org and encoding.com. Both of these sites enable you to upload your original video format and then encode it into a range of different web video formats that can be used inside of the HTML5 web and audio tag. Another approach is to use cloud storage like the Azure storage. And if you're using storage in this way, it's important to note that you may need to log in and change the MIME type or the content type of the video to the specific content type associated to the file format. So if this is MP4, you'll need to choose video-MP4. If it's OGG, it's OGV, video-OGG, or video-WebM for WebM video. In addition to that, if you're wanting to seek ahead in a video, so if you're using or displaying long-run content, which is maybe half an hour or up to an hour long, you need to have an HTTP 1.1 compatible web server. The advantage of this will enable the user to seek ahead to the end of the video instead of needing to wait for that content to be downloaded. IIS supports with Windows Media Services 4 also supports the ability to do bitrate throttling against your media, which means that you don't download more than the user is actually needing to watch. So let's, after all that, go ahead and have a look at an end-to-end demo. I've built down here a test site for my demos. I've done this using MVC3, using the HTML5 project editions that Scott Hanselman showed at the keynote of Mix yesterday, and I'm hosting this on Windows Azure inside an extra small instance. So if I come up here and I click Start, this is the test page here at video.stickon.me, so you can test that out yourselves from home. And this is a standard video that's being hosted on archive.org and downloaded and played using the video tag specification below. It's going to play the MP4 video first and then fall back to the OGV video, and you'll notice I'm using script here to get to the video element and set the volume to 1. So if we have a look at that, you can see the volumes being set default programmatically. Over here, if I play back my video, there's my video playback using the native controls inside of the browser. If I was to click here and play back from my local IIS, you'll notice I get across here like a missing image. And the reason for that is IIS by default doesn't set the MIME type or doesn't understand the MIME types of the new web video formats. So it doesn't know about .mp4 or WebM or OGV. So you need to add these either here using IIS in the IIS Administrator console or via the web config in your files. So now I'm going to add video MP4. I should be able to switch back to my application and press F5 and have this video load and play back from my local IIS. In addition to that, if you've got media services installed, you can click down to this bitrate throttling and set or enable bitrate throttling for media types. Here, if I enable it, I can say download as much as you can in the first 10 seconds, and then throttle the downloading rate to the same encoding rate of the video file itself. This will save on bandwidth if people are leaving the page there but not actually watching or fast forwarding on the video content. The next thing I want to show in my demo, I'm using Windows Azure Blob Storage to play back this video, which is a presentation of my session that you're watching right now. You'll notice the playback starts, and if I try and actually seek to the end of this video, it won't let me because I haven't downloaded that content yet. And the Azure storage today doesn't support byte range seeking that I'm going to talk about next. So if I click on the same example where I've got the video hosted on IIS and then served out via Akamai's CDN network, I can play the video back here, and although I haven't pre-downloaded the end of the video, I can actually scrub forward to say 10 minutes into the video and start watching this demo playing back at the same places I'm currently up to. If you wonder what's going on here, if I just bring this down and press F12 and bring up the dev tools inside of IE9, if I click over here and start a network trace, as I scrub this video, what you'll notice is happening over on the right hand side is that we're making a request of the video using a specific byte range. So over here I'm saying bring back the MP4 video using HTTP 1.1 and requesting from this particular bytes. And what that's going to do is return chunked video back from where I'm actually up to in the playback. Just to show this also works using other video formats in other browsers. If I launch Firefox here, I can also hit the same IIS site, start playback. This time it's playing the OGV video rather than the MP4. And if I seek forward to 10 minutes into this video, what you'll see now is that Firefox is seeked forward and is playing from further on in the video where I'm up to. So the same demo working from IIS but across a different video type. The next thing I want to talk about is HD video. Now, a lot of people use the term HD video on the web, and I think it's become somewhat diluted over the recent times. When we talk about HD video, we could be talking about 1080p, 720p. What's the frame rate? 10 frames per second, 60 frames per second? What's the bit rate? Is it 700 kilobytes per second, or is it 20 megabits per second? Really what it comes down to is what is the optimal encoding rate to make your video look really good for your users. So if you look at this example here, this is actually a screenshot that I've taken from Chrome H.264 decoder, and you'll notice that there's an area of corruption down here in the front of the video. And that's happened because the decoder has not been able to keep up and has actually dropped some intermediate or reference frames from my video. So you might be asking yourself, are there encoding settings that we can use to reduce this sort of corruption? Luckily enough, the answer is yes. If we think about H.264 as a codec, it was designed to work on everything from battery-powered devices right through to very high-end GPU or hardware encoding. So what that means is, as a person encoding this sort of video, you can encode at a baseline profile, which is going to give you a larger file, but it's going to be less complicated to decode and quicker to encode, right up to a high profile, which is going to result in a smaller file downloaded to your users. It's going to have more computing power required to decode, and it's going to take longer to encode. Traditionally, people would target the main profile rather than the high profile, but this has changed over recent years because most devices that support main also support high. And I'd recommend just using high because it's the same level of complexity to decode as is main. For Microsoft technology, there's many encoders that you can use, but Microsoft Expression Encoder 4 Pro offers you some really good options to avoid the sort of corruption that I was showing before. So if I bring up Expression Encoder 4, what you'll notice over here, this is actually a 1-minute video that I've taken from my digital SLR camera, and it's 145 meg in size. And if I move up here, there's a default profile for YouTube HD in H.264. If I apply this to my settings, you'll notice that it's moved to the main profile for H.264. I might want to move this up to the high profile based on the comment I made earlier. If I drop down this video tag over here, by default it's going to use constant bitrate in a single pass. I might want to move this to variable bitrate and make it constrained. And the reason for this is that I can have a lower average bitrate, say 700 kilobits per second, but I can peak to 3 megabits per second when there's a lot of action or a lot of movement inside of my demo. Down here, the size mode has been moved from 1080p down to 720p, which is fine. And what I wanted to do was actually ensure that I use stretch as opposed to letterbox because we're reducing our input formulas, our input resolution. Now if I drop down to some of the advanced settings, it'd be good to increase the number of reference frames in my video and also increase the number of bidirectional predictive frames that sit in between those reference frames. By doing this, I'm going to improve the efficiency and the ability to seek across my encoded video. I'll increase my search range as well. And then down here, one thing that's really important is when you increase the number of bidirectional frames, make sure that we unclick the reference B frames box. And what this is going to do is ensure that the encoder is able to drop these bidirectional frames and not cause the sort of corruption that we saw earlier in the screenshot. If I use the Hadamard transform, I'm going to actually get a higher compression rate and an even smaller data size. So those settings are there. I might want to come into my audio and potentially change it from 192 kilobits to something a little bit lower, maybe 128. And we're all done and ready to encode our video. So the next thing I want to talk about is Canvas and CSS, and how Canvas and CSS can be worked alongside video to create some pretty amazing experiences. I'm going to start by showing a demo of using Canvas with video. Now what I want to demo is this amazing fireworks site from Beauty of the Web. One of the interesting parts about this is that because these videos all need to be downloaded, it's really hard to keep them all in sync. So if we have a look behind to see what's happening, you'll notice it's one MP4 that's being brought down, and it's full of all the video tracks. And then what's happening is that we're cutting this video up using Canvas and playing it out and allowing the user to interact with the video. Why might you want to be able to do this? Well, think for example, you're watching me with a recording of my laptop here, but you might be hearing the cicadas in the background. So if you click that little button over to the side of the video, click it now. Hey there! Now you're getting more information about the environment that I'm actually recording this in. Hello, there's another camera over here. And as the user, you're able to click between cameras and presentation and get that feedback. So what I wanted to show you is how that you can use Canvas for this effect. First thing you need to do is you need to include your video element down on the page. And in this case I've set it to autoplay and preload to auto so that it starts straight away. I need the width to be the full length of the video. So in my case here this is 1920 by 1080 and I've set that width to 1920. I'm actually making sure that this video is not displayed on the page, so I'm hiding it from the user. I then have a canvas element which is the width and height of my clipped image. Down here, when I'm loading the metadata, so when I know the duration and resolution of the image, I initiate my controls. I get the source video and the canvas element. I get its 2D context, and then I call the process frame method every 33 milliseconds or 30 times a second. Then down below, I'm going to actually process this frame by passing in the video and drawing to the canvas the current frame of the video using the cropping and scaling that I require. So the thing I really like about this demonstration is that as the video is playing back, the video is being profiled and then the canvas is displaying the dominant colors down the left and the right hand side of the video on playback. So you may be sitting there wondering why I'm using Canvas to do things like clipping and redrawing of the video content. If you're a designer, you're probably thinking that CSS3 and some things such as border radius or box shadow could provide the clipping that you require to do this against the native video element. Well, unfortunately in my tests, I had tried to take a playing video element and then apply border radius and block shadow and box shadow and transforms using the vendor prefixes when required. And I found that only IE9 and Firefox 4 did as expected and cropped the video accordingly. The other browsers, while the video was playing back, resorted back to a full letterbox experience of the built-in player. If you want to have a look at this, I'll bring up the example inside of IE9. And if I just zoom in here while this is playing, you can see the very nice effects from the CSS with the radius and also the drop shadow here. So that's CSS transitions. The fourth thing I want to talk about is building your own custom controls against the media elements. If we have a look at this again, I'll show you this is all of the native video controls against the browsers on Windows. So we've got IE9, Chrome, Firefox, Opera, Safari. And you'll also notice that IE9 changes its video controls based on the size of the video on the page. So if you're putting a video in a very small space, it's not going to show the standard scrub bar, it's just going to show a play pause button on top of the video. But you might be thinking that you want to create your own player controls or have the player controls look consistent across all the different browsers that you're using. So in order to do this, what you'll need to do is write your own player controls as opposed to using the browser ones out of the box. There are some media element methods to help with this. There's play, pause, can play type, and load. You need to use load if you're changing the source file or the media content while it's playing or dynamically. The media element events, you can add listeners for the common events such as play and pause. And I'll show you how we do this using the form of a demo. So if I bring up my demo here for custom controls, this is an example with some custom controls that have been created. As you'll see the video playback here, it moves along. I can pause or play this video content. I can also bring up the source code and I'll just have a look at this. I'll just increase the text size here. And as you see, there's a bunch of CSS and styling elements. And down here there's some event listeners against the specific media events that fire. There's one for play, pause, when the video's ended, progress, duration change, time update. These are as the video file is downloaded or as it's playing back or the time to play or durations are changing. I can also do things such as grabbing the playhead and rewinding it to further on in the video. It's an example of rolling some of your own custom controls. The next problem or opportunity that we face, I talked about not all of the browsers supporting full screen video, being because that full screen video is specifically not part of the HTML5 spec, and there's still debate over how it should be added for the browsers to implement. But there are some workarounds. The dev channel in Opera have built a JavaScript engine called videofullscreen.js, and if you include this, this enables you to go full screen on your native video controls by pressing Shift Enter or F11. So if we have a look at this demo here, I can bring up my full screen demo, and here's the video playing back. Once it's playing, if I press F11 in my browser, I'm now popping to full screen, and I have the full screen or the full window playback with my controls visible. Press 11 again and I'm back down inside of the page. And the last thing I want to talk about is HTML5 players themselves. There's a lot of work that's being done to create custom video players that you can use inside of your own web applications. This is just a list here with a whole bunch of different licenses, JavaScript libraries. Do they support Flash or Silverlight as a fallback? Do they offer full screen or full window mode? Is there keyboard access for accessibility? and are they easy to integrate? The source for this is Video SWS that you can do a search for. I've experimented with a bunch of these. Some of the common ones: JW Player. Anyone used to using Flash? JW Player now has a Flash player that falls back, an HTML5 player that falls back to Flash. There's ones such as Leanback Player, which supports a lot of keyboard controls, and Skip Play. MediaElement.js. The one that I find very interesting is the Sublime Video, and the reason for that is it offers you a player as a service. And what I mean by that is that they will host the player for you on their own CDN, and they'll deliver it down to you in your client. The advantage of this is that they will fix any browser bugs or changes as they come along, and it will roll out and automatically be implemented inside of your code. So if we have a look at this in a demo, this website here enables you to play your own video content against a range of different players to test from. You'll notice the player remembers my volume settings from the previous time I was here. I can do things like switching between HTML5 and Flash. It's now playing in Flash. It's now back in HTML5. I get the same look and feel across my video. I can do things like going into full window mode like we saw before. I can hide those player controls and then bring them back and come back into my in-page experience. So this is the Sublime Video Player. In your own sites, you might want to do fallback. I personally like the idea of falling back to something like YouTube. YouTube now enables you to store unlisted videos and long-run content. So for example here, this is my previous demo of my entire session. If I bring up the DevTools again inside of IE9 by pressing F12, I can change to IE8 here. And what you'll notice is that the page will reload and will fall back to a YouTube version of the same video file as we saw previously. So this can be your fallback experience that you provide to users that don't support the video or audio tag. Now, that's pretty much all I wanted to cover in the time that I've got today, but I recommend you go along to ietestdrive.com and check out the demo, specifically the Firework Canvas video devo, and also the WebM HTML5 edition for IE9. Microsoft yesterday has launched a new website called microsoft.com/media platform that talks to our end-to-end media platform offerings. And if you go to nigelparker.name, that's my blog and all the details about me, and you can find the code samples as well as the video of this session. Thank you very much.